Good morning, everyone. My name is Helen CHAN. I'm a BIM manager of China State Construction Engineering Hong Kong Limited. I'm responsible for the BIM implementation in a civil project called 3801 APM tunnels and BHS tunnel on existing airport island. Thank you for inviting me to AIAB annual conference today. I'm glad to be here to share about our new practice on a BIM-based NEC civil project. First, let me share about our project background. 301 is one of the major contracts of 3-one-way system project of Hong Kong Airport Authority with an investment over $2.37 billion. China State Construction Engineering Hong Kong Limited is the main contractor undertaking the construction works of 301 using NEC 3 Option D contract. We are committed to our clients' success by undertaking every project with highest level of professionalism, precision, and care. And BIM has played a critical role in reforming the information flow throughout the project lifecycle. We are well positioned to overcome different challenges with the innovative solution and practice of BIM. The project involves an APM tunnels. From the video, you can see that an APM tunnels, a BHS tunnel, a box culvert, and a jet box tunnel underneath the existing airport express line, and a ventilation building, 13 disciplines of underground utility, and a series of temporary works to satisfy the evolving list of the project. This project has a significant part of 3RS project for the connection between the expanded Terminal 2 and the T2 concourse on newly reclaimed land. The core value in our project are management of information exchange, data accuracy, transparent and collaborative working. I will explain in more detail in the following slide to describe how our team utilized new practices with BIM solution to achieve desirable outcome in quality, commercial, and technological aspect. In our collaboration workflow with AA and design consultant, BIM acts as a collaboration platform for design review and constructability review. We have gone through different processes for modeling checking, clash detection, site create procedures, and drawing generation. Finally, it's the handover procedures. All the task teams like construction team, survey team, QS team, and planning team are involved in the BIM collaboration. The whole information exchange procedures is carried out at the common data environment, Autodesk BIM 360. We are working closely with AAHK to practice collaboration in project management. BIM and NEC contract share the same concept of cooperation and spirit of mutual trust. In order to enhance communication by establishing an effective BIM workflow for potential dispute resolution, we have set up a project team with an NEC and BIM workflow that is capable to create and adding values to our project and also the BIM models. We have formed a compensation event quotation team. This team comprises of 7 full-time members of BIM engineer, quantity surveyors, engineers, and programmers to facilitate the management change throughout the course of works. This project team is fully utilized BIM 360 Docs as a one-stop platform to view, use, and alter information for the smart decision and risk management throughout the project lifecycle. In the project, our team proactively proposed a value engineering design using BIM for quantify the changes. And those value engineering design eliminated clients' risks. During the risk reduction workshop, BIM models also play an important role for open communication and high transparency. Apart from the NEC and BIM collaboration workflow that I have talked about, another highlighted new practice in a project is BIM-based underground utility management system. This system assists the project team managing 13 disciplines of underground utility within the construction site. Unlike the traditional method, from modeling, detecting potential problem to generating shop drawing. This system is performed with the use of BIM and AR technologies to identify design uncertainty and to review the feasibility and constructability. Even when you are an engineer sitting at the office, you can fully familiarize the UU condition on the site. Here are our procedures. Like first, we first standardize the civil 3D template, such as the part builder library, pipe and manhole style, and do the modeling based on different SB record, Sharpie record, cable detection record, in order to get a full picture of the existing condition for future coordination. After that, we carry out clash detection between proposed UU and existing UU database. So engineer, designer, and even clients, they will hold workshop to coordinate a feasible routing of the proposed underground utility. After getting a feasible or clash-free routing, all the setting out drawings, longitudinal profiles are automatically generated from our BIM model using Civil 3D. Before the construction work starts, the engineer will make use of the BIM model to review the existing UU location before they getting the permit, like the permit to dig and the permit to drill. Then the survey team will take the as-built record and pass the record to BIM team for as-built modeling. This system forms a cycle to enrich the information in our UU database. Proven by statistics, it resolved 90% of the UU issues because this BIM-based management system for UU is effective in providing a full picture for coordination and also reducing the risk for abortive work and the damage of existing underground utility. And we also use AR technology to bring the BIM to life. Apart from the UU management system, and we also utilize BIM as a virtual design coordination platform. The direct data transfer from reference structure and structural analysis software allows the engineer to have a seamless collaboration within BIM team. This is applied to the design works of different temporary works like our airport road traffic data and the Changhong road traffic data. Here is the procedures. Design team first import the BIM model into their structural analysis software and perform the analysis. Once the design team delete or add an element, the BIM model will update accordingly. Then this direct data transfer enhance the efficiency of design coordination and clash analysis in design stage of the temporary works. In such a large-scale ELS project, the control on the conflict between the permanent structure and the temporary storing is one of the big challenge. From the video, you can see that within approximate 400 meter times 120 meters cover them, there are 4 layers of ELS, 3 numbers of traffic data, 3 sets of working platform, and a series of temporary underground utility supports. This video that you are seeing are the capture from our point cloud image. It's really congested. There are only inches for very limited adjustment when we are doing the design coordination. We apply BIM to eliminate 95% of foreseeable conflict during design stage to reduce the time for site coordination works and abortive work. We also use 4D BIM to plan the heavy lifting in congested space and also the load of above ground works. So from the right-hand side, you can see the before and after image to see how we solve the clash of the ELS before we do the construction works. And 3801 is the second project to carry out box checking technique in Hong Kong construction market. One of the critical challenges to avoid the disruption on the operation of AEL with strict settlement requirement. With different BIM's application, our team has taken immersive step forward in both in mitigating the working restriction and bring forward new ways working. As we all know that unseen underground condition has high level of risk and uncertainty. Within the box jacking zone, our team modeled the geological condition to fully visualize and utilize the complex geology. And we also justify the position, foresee the problem, and analyze the geological condition with other construction tasks to monitor the workflow during deep excavation and box jacking tunnel. All the activity can be viewed in one single platform for coordination, which is in our BIM model. Also, we also extract total volume in cut and view between the soil and rock in 3D geological model of box jacking zone for further analysis. Those data input and extraction are done by the API to bridge the models and data together in order to build element automatically. From the last slide, the box jacking methodology is clearly reviewed together to using phrasing plan and sequence model. Based on different scenario, planners and engineers can select the feasible construction and the site logistics scheme in order to optimize the construction schedules for risk mitigation. Scan to BIM application is another method that we have applied in 3801 to accelerate data capturing time and also the data completeness. We take laser scanning as a part of BIM process to enrich data. Our aim is to synchronize site data and BIM models. This scan to BIM make modeling, updating, and also verifying measurements effectively possible without having to leave the office, like bringing the existing condition into our engineer's desktop to take accurate and point-to-point measurement with our BIM model. Here are some applications example of scan to BIM. First, we take it as a site record for design review and resolution. We scan the existing UU and append the ELS model to review our ELS design. This helps us to optimize our design with accurate data. It also reduces the risk when collecting information from dangerous or hard to reach location. So keep our surveyor in a safe condition. For the existing UU verification and safety analysis, sometimes some location is hard for survey team to take the survey record of a bunch of cable on site. And also it really takes time to model it. So in order to increase our efficiency, we scan it and use recap and Navisworks to evaluate the site condition. We also use the same set of point cloud to showcase how the site has changed to improve on-site safety measure. It can achieve two ends with single effort. Like detailed site information also reduce the dispute with interface project. The actual size is vary. Sometimes the actual size is vary with the design model. It totally affects our ELS design. So we scan the site in every excavation level to record the change and the quantity of the abortive work by using the volume dashboard function in Civil 3D with our point cloud model. Because 3801 is a mega scale ELS project, so we have scanned every layer of the ELS. When combining the point cloud data and BIM model, the engineer will have a better insight to the project to predict the coordination problem. Here is the example. Because The ability to capture those detailed information about the ELS allow a more precise use of the data. Because in the realistic 360 immersive image provide real-world comparison tools that enables construction team to spot the difference and problem quickly and easily. It helps to analyze the logistic planning and also the construction sequence in depth, therefore improve spatial analysis, accessibility, engagement, and understanding. The data can also be used for safety measure, progress monitoring, and risk assessment. Our team fully utilized 4D BIM for resources allocation, site logistics, live traffic diversion, and risk mitigation. We generate accurate phasing plan and sequencing model that helps communication and collaboration with different project teams, especially planners and engineers, like 4D simulation for master program to demonstrate the 4D simulation to demonstrate the interface issues, traffic diversion. They can access the material and resources and the progress tracking. So different scenarios are also presented to them to select a feasible site logistics scheme. Those 4D simulations are also attached in the method statement for submission. 5D cost estimation is another key application in 301, especially in our BIM and NEC collaboration workflow. During the 5D BIM process, it is all about whom we are sharing the model, for what purpose, and how to connect BIM data and BQ with high level of freedom. So modeling practice and guideline is well discussed with our quantity survey team before modeling in order to make sure the BIM elements are matched with the BQ items, like the underground utility and the tunnel structure. Those are modeled in Civil 3D using pipe networks and corridor. We get the pipe and manhole schedule and the volume quantity using schedule and volume report function. Directly generate the raw data from the Civil 3D by type and chainage. Then the QS will get the quantity and put it into the BQ. So in 301, all our quantity surveyor are trained and get involved into this approach. So most of them, they will download the model from CDE and get the information that they need. We have been through a lot throughout these years to achieve seamless collaboration, estimation, and visualization. We also changed the way how we work together and the way we communicate with high transparency, open communication, informative data, and effective collaboration to reduce 80% of risk over 90% of UU clashes, minimize the loss, and most importantly, to achieve a win-win situation with our clients, AAHK. Hope you enjoy my sharing. Thank you.